I've worked on heating for about 20 years, and for most of my career in the energy space, the heating discussion looked a bit like this. It was really the elephant in the room for a very long time. The discussion that in the energy space I observed was very much about renewables, electric vehicles, batteries, maybe hydrogen or CCS, but heating didn't really get a lot of attention. That is now changing, and I believe, and that's why I titled my presentation in the way I did, I believe heating is going to be the next challenge, for the next decade. We've kind of done the power sector, not completely, but we're on a very good track now, but heating is the next big challenge in front of us. And that's both heating in buildings, but also industry, although I'm not going to comment on industry today, because this is about heating in buildings. I have three parts of my presentation, just to give you the heads up what's coming. Bit of context, then I want to talk about individual home heating, and then talk a bit about district heating. So these are the three parts before I wrap up. Let's start. Let's look at some of the context. And I think what's quite important is to look at the current situation in Northern Ireland, which is not looking great when you look at the heating fuels currently being used. From a climate perspective, most of it is fossil fuels, a lot of oil, and quite a bit of gas as well, but highly carbon intensive. That's the main takeaway here. And when you look at the share of renewable heating systems, that's 0.34% on this chart here, based on the latest statistics. And yes, there's some electricity in here too, but that's also not very much at all. So overall, a heavily fossil fuel dominated system. On the other hand, when we look at the share of renewables in the power sector in Northern Ireland, it's now approaching 50%, and in fact, in some months, is already exceeding that. So we're actually seeing some pretty impressive progress when it comes to renewables in electricity in Northern Ireland. And this is mainly wind, of course. This is not so dissimilar to what we see in other countries around Europe. Here's a graph which I shared the other day on social media. I was quite surprised by how far we have come. And you see the green line is the production from renewables, solar, wind, and hydro across the European Union. And then you have on top the fossil generation as a percentage of total generation. And you see now for the first time last year, actually renewables have outperformed fossil fuels. And this does not include biomass, which is often mentioned by skeptics of the transition as the kind of main driver of renewables. It really isn't. When you look at electricity, it's now solar, wind in particular that are driving the transition away from fossil fuels. So overall, good news on electricity. Going forward, we're going to see more of that as predicted by analysts, and government targets have been set in the UK, the US, in the EU, to completely decarbonize the power sector at some point in the 2030s. It could be in the late 2030s or the mid 2030s. If we have an election coming in a few weeks' time, and the outcome will be that we have a Labour government, they want to do that by 2030 already. The overall message is here, we are on a trajectory towards low emissions, perhaps zero emissions in electricity. The other good news is that there is an awful lot of heat around us that is currently unused. We have ambient heat in the rivers. We have ambient heat in the sea, in the ground, and in the air. And it's a resource that is abundant. There's so much heat around us, we can't use it all up for heating our buildings. There's just too much of it. The main challenge is, how do we harvest it? How do we actually make use of it? And that's where, and I will talk about heat pumps in a minute, electrification of heating can play a key role, because you're essentially getting cleaner electricity and then using that to harvest that ambient heat, which is renewable and is free, essentially. The main cost is the electricity and the technology. And this could reduce final energy demand dramatically. So we're currently wasting a lot of our energy because of the way how we use it. And this is analysis by a colleague of mine at Oxford University, Professor Nick Eyre. He's calculating that by electrification, we could reduce final energy demand by about 40% globally. This won't be so dissimilar in Northern Ireland. Huge reduction potential and an increase in efficiency by doing this. Right, and now I want to move to individual heating. and talk a bit more about heat pumps after sort of spitting out that electricity is getting cleaner and there's an abundance of ambient heat resources around us we can use. Of course, heating of individual buildings is complex, right? This is the city of Oxford where I live and where I'm speaking right now. Lots of individual buildings, different building types, old architecture, difficult to treat, very dense urban area. So heating is hard. It's harder than telling some of the power producers to switch to renewables, as we have done in the past. We're dealing with millions of people and millions of decision makers here. So fabric efficiency is still important, no doubt, to bring down the emissions from heating and the heat demand and the running costs. And we have calculated, this is now a bit dated, 6 years ago, that for the United Kingdom as a whole, the potential for fabric insulation is still very, very large. And overall, energy efficiency could reduce energy demand equivalent to 6 Hinkley Point C power stations. Of course, most of the heating isn't electric, so the comparison isn't quite accurate, you might say, but it gives you a sense of scale, just how big the opportunity for further efficiency still is, even after many years of trying to insulate buildings and make them more efficient. That's only one part of the equation. The other part is heat supply. And heat pumps, not just in my view, but pretty much in the view of most analysts around the world now, are seen as the critical technology for decarbonization of heating. And that includes both individual heating systems and district heating. I come back to that in a few minutes' time. On the left-hand side, you see the stock of heating equipment as projected by the International Energy Agency for 2050. The turquoise or light blue piece here, that is heat pumps. So about 55%, they believe, will need to be heat pumps by 2050 in order to meet the net zero goals. On the right-hand side, you see a McKinsey study that looks at sales, so the equipment sales of heating systems, and most of the sales, about 90%, a bit less perhaps, in 2050, they believe should be heat pumps. So clearly, heat pumps are seen as important, not the only technology, there's many others, but they are the key technology, at least when you look at most of the studies that I have seen. And why is that? Well, simple reason. A gas boiler, or an oil boiler, which is common in Northern Ireland, you always have losses along the way. You're essentially putting in more energy than you get out. That's what you see on the left-hand side here, because you have leakage already at the well stage, transmission losses, and then losses in the boiler itself. A heat pump is kind of the mirror image. You're actually getting more out of the system than you put in. Which seems very awkward, but that's exactly how heat pumps work, because remember that ambient heat, that big resource we have, is already there. So we're just using the heat pump to move existing heat, compress it, bring it up to a higher temperature, and that makes heat pumps so efficient. And that's why they show up in most of the modeling as a key technology. We have already installed 200 million of them around the world, which is, it's pretty good, but we're not going fast enough. There's a big gap still between what the International Energy Agency believe is needed and where we currently headed. We've written a paper a couple of years back, sort of looking at the global heat pump market, and this is what we found. The other important finding from that work is that actually most heat pumps that are being installed currently are in the coldest climates. And this is a rather busy graph, and I'm just going to walk you through it quickly. So on the x-axis, you see the number of heat pumps per 100 households. In other words, the penetration of heat pumps. So the further to the right you are, the more heat pumps you have. In other words, if you let's say you where Norway are, that's about 60. So about 60 heat pumps are currently installed in Norway for each 100 households. It's now a bit more because this data is a bit old now. It's think from 2020 or 2021. And then the higher up you are on the chart, the colder it gets. This is measured in the number of heating degree days. And what you find is the coldest places also have the most heat pumps, which is surprising given that people often say heat pumps don't work in cold climates, but clearly they do. Otherwise, people wouldn't install them in Finland and Norway, Sweden and Estonia in such large numbers. And indeed, when we zoom in on those places, you see on the left-hand side the deployment over the last 20 years. Most of that has happened. Rapid increase in deployment of heat pumps of different types. Initially mainly ground source, then increasingly air-to-air, and a little bit of air-to-water and exhaust heat pumps as well. And on the right-hand side, you see the impact on carbon emissions not just heat pumps, that's also fabric efficiency and district heating, but heat pumps played a very significant role here in that downward trajectory of carbon emissions from residential heating. However, we're still in a debate in the UK that looks a bit like this. This is a very common headline you will see in lots of the UK media, full of myths and false information not based on science and evidence, in some cases funded by vested interest groups. That's been exposed by DESMOC, I think a year ago or so, funded by the Energy Utilities Alliance. And of course, a lot of that is nonsense. And I've written a fact check with 18 misleading myths about heat pumps for Carbon Brief. It's thousands of words long. If you really want to look at the detail, there's lots of sources there that debunk most of these myths. I hope it's a useful resource for those of you who are interested in that sort of thing. How do we scale heat pumps further? And what could Northern Ireland potentially do as well? This is one of the questions that we've asked ourselves. And we produced a policy toolkit that we launched in Egypt at Sharm el-Sheikh at the climate conference. And we essentially have three main pillars. One is to make sure we get the pricing right. Too often, the main reason why people buy fossil fuel heating systems is that they are just cheaper to run. Because we don't put a carbon tax on the other fuel, on fossil fuels. And we also put a lot of the policy costs, the costs for scaling renewables, etc., or energy efficiency on electricity. So that imbalance needs to be sorted out. And unless we do that, it's going to be very hard to persuade people to buy a technology that's more expensive to run and to keep warm. Some upfront funding, grants, rebates, loans will still be needed because of the high upfront cost and regulation. We're now seeing increasingly new buildings and no longer allowing fossil fuel systems, but also the replacement of existing heating systems increasingly around Europe. And now also in the US, we're seeing that regulation is being deployed to make sure we move to clean heating. And I want to talk about district heating very briefly, because that's also a very important, I think, technology that is overlooked in the current discussion. District heating has a huge potential. You can see Northern Ireland actually here, where the potential is somewhat smaller, but across the UK, it's about 20% of district heating that the government commission analysis suggests could be deployed, which is very, very large indeed. And that would be using a whole range of sources. Could be waste heat from the sewers, from the underground in London. It could be, from the air, from the ground, seawater. There's actually a huge seawater heat pump in Esbjerg in Denmark, the largest one in the world, 60 megawatts. I don't have a picture of that here, but huge potential for district heating. Just very quickly, some countries have already reached very high shares. Denmark, Sweden, 50% plus of district heating for buildings. And much of that is also renewable, although it's still a lot of biomass in those places, to be fair. The UK doesn't show up on this graph. It's only the EU 27. It would sit in the very bottom left corner, close to sort of maybe Spain, Belgium, Greece. And that is simply because the share of renewable energy in district heating, which is here depicted on the y-axis, and the share of district heating overall of total consumption for heating is very low. And here you see it. So currently only about 2% of heating in the UK comes from district heating. And most of that is fossil fuels, very, very little renewables in here, a bit of electricity, a bit of bioenergy, but it's largely natural gas, fossil gas, again, based on the most recent figures I could find from the UK government. So we have a long way to go if we want to scale district heating and also clean it up, but the potential is very, very large indeed. And here's one of those big heat pumps that I mentioned before. This is not an Esbjerg. This is one I visited in Copenhagen, and it's connected to the district heating system there. And it's using seawater as the main heat source. This is only 6 megawatts. So imagine what the 60 megawatts unit would look like. That's 10 times larger in terms of capacity. These are real monsters. They're huge machines, very impressive indeed. If you ever get a chance to see them, I highly recommend it. It's quite an impressive achievement of engineering. Right, so just 2 or 3 words on hydrogen. I just have to throw this in there and then I wrap up. So often the question comes up is why do we have to do all these complex things, electrification, fabric efficiency, heat pumps, district heating? Can't we just have hydrogen in the pipes? Well, the answer is you could potentially, but the evidence suggests it's not a good idea. I've reviewed now 59 studies. The last meta review I published was in December when it was 54 studies. It's now 59. None of them suggests a major role for hydrogen in heating. Yes, in some niches, waste heat from electrolyzers and district heating, potentially, that makes sense. Maybe in very cold climates, near an industrial cluster, but not at scale, not to replace the gas and the pipes. You can see here some of the institutions that have commissioned research on this, produced research on this, and it's pretty unanimous. The main reason is higher cost, about 2 to 3 times higher consumer costs, and efficiency is quite poor. Let me wrap up. All of this sounds difficult, hard, expensive, complicated, and it is. And it's a bit like going up a steep mountain pass when this is at the Tour de France, I think the highest point in the Alps. And you never quite see where the next bend is of the curve. You have to go up. You need to go over that pass, but you're not clear exactly where it's going to take you next, that road. And I think it's a bit like that with decarbonization of heating. It's a long, steep road ahead, and we don't quite know exactly where it takes us. More innovation will happen along the way, but to the mountain pass, we will have to get eventually, and I think we will. I'm an optimist. I think this can be done, and there's great opportunity for innovation for a cleaner, more sustainable future in the heating sector. Thank you so much for listening, and I look forward to any questions, comments, and the other presentations. Thank you.